Hello everyone, my name is Timothy Lee Grant and welcome back to another video where we are trying to learn how to become a software engineer. Today we are going through Java. All right, so in the last video I was trying to get something that just worked. Okay, so I'm just starting out with Java. I tried it a long time ago. I got essentially like a hello world a year ago. I've forgotten everything. Now I'm trying to get back into this language because I know that it's extremely important. Not only just the language is important for software engineering, but also the concepts which live in the Java ecosystem are also extremely important. And that was one of the questions that I got on my couple videos ago was they were asking me, well, why are you doing JavaScript and Java? Why are you doing so many projects in so many different languages, right? And the reason is because, yes, the language is different, but what I'm really trying to get at is the ecosystem which these languages live in. So with the JavaScript, project, the ecosystem is more of the REST APIs, how to deal with servers, how to deal with databases, how to handle requests. All of that is kind of how to service HTML files or EJS files or what is Node.js, what is Express, how do you format, how does HTML and CSS interact, how does JavaScript interact with that on the browser side and on the server side. So all of that is living within the JavaScript ecosystem. Okay, now I am trying to ask myself, okay, well, now, in the Java ecosystem, this is completely different. I am trying to figure out, I know that there's JUnit for testing, so I need to be able to do, I feel like Java is more of production code that I'm able to develop pipelines with. I'm able to figure out how to create I'm not really sure what I need to learn in Java. That's kind of the entire thing of these series is like, okay, well, you don't really know what you need to know before you start, but that feeling shouldn't make you terrified to take a first step, essentially. So I'm trying to figure out like what is in the Java ecosystem that I really need to be able to understand. I know because I talk to people and I know that software engineers at those big companies use Java. That's how they do a lot of their production code. Okay, so if I want to be able to get into those positions, I need to have, yes, again, I don't really care about the language. I don't think that the language is that important, honestly. Like if you use C++ or C or Python or JavaScript or right, okay, it's just syntax differences, right? The question is the ecosystem which it lives in. Okay, well, how do those decorators work? How do those annotations work, right? Like, how do, in certain languages, in certain frameworks or ecosystems, there's going to be a lot of differences, not just like in the syntax, but in how the language is actually being used. And that's kind of what I'm trying to get at. I'm thinking that Java is going to be able to teach me how to build larger scale projects. I'm going to be able to do a lot of the testing, the pipelining, um, and make sure that I understand a lot of those object oriented programming concepts, etc. And then from there, then maybe try to figure out, okay, well, in the Java ecosystem, where should I be pushing so that I learn exactly what is important for those roles within software engineering? So that's kind of why I'm doing what I'm doing. I'm not a professional. I don't know all of the answers. I don't have a clear roadmap either. I'm kind of winging things as they come up. I've been very upfront about that, right? Like, I'm certainly not a professional. My degree is actually in electrical engineering, and I work now as an embedded systems engineer. So I'm more of an electrical engineer than anything with like software, right? So that's kind of how I'm trying to just the first step, just take a step, right? Just like find out what you need to do, move forward, even if it's wrong. Even if, like, for example, I'm trying to do Spring Boot right now in Java. Okay. Well, even if I completely fail at it, I have learned a lot of concepts that I previously had never even heard about. Now I have a starting point. Now I tried to do something, I failed, but at least I have a starting point now. I'm not back. I might be back at the same position, but now I'm much more. I'm have a map. I'm like, now I can go in this direction because I know about it. Now I know about Maven and Gradle and how Maven is actually orchestrating the different projects, right? Like, now that makes sense to me, even if I completely failed it, right? Like, I feel like there is a lot to the idea that just playing with things and interacting with different concepts is extremely helpful when learning it. So not trying to be petrified in fear of not knowing something, or just like not rushing into it and just playing. So anyways, that's kind of the context why I'm doing this, why I'm creating a new project, even though I'm already doing a JavaScript project. And things are definitely going to be more dynamic insofar as, if I'm feel like I'm spinning my wheels in the Java project, okay, well then yeah, I can try to reassess things and figure out, okay, maybe I need to take my foot off the pedal on the Java project and move forward faster on the JavaScript project. And it's just dynamic. We're just going, okay? So I have a project here. Okay. And we were able to run it. So I come here to new terminal. This is here. So now I do the mvn, and I believe I need to do from here mvn, and then forgot the command which it told me to do. Let me see. It was something about Maven run. I remember that. Okay. Where is it? Here we go. mvn w spring boot run, like that, right? I believe so. Then, okay, so this doesn't exist. Yeah, well, I agree it doesn't exist because I didn't write it correctly. Okay. V-N-W. Okay, here we go. So now it's going to run. It's doing its thing. Okay. There we go. Now I should be able to come here and go to localhost 8080 and go to this hello, and it should, bam, we get this. Okay. So now that's kind of where we are. Source, main, Java, and then here. So I'm sending back this hello from Spring Boot, and then I made sure that this is actually what's being sent back by just creating this random string. Okay, so what do I want to do in this video? I got something to work. my methodology for doing these, for doing projects when I'm trying to learn something is, first off, get something, anything that works. Once you get something that works, once you have a golden copy, okay, now it's time to back engineer it and figure out how is it working? Why is it working? What is it doing? What's going on here? Okay, so that's what we're going to be doing in this video. We're going to be investigating this. We're going to be back engineering it. We're going to be trying to figure out how it's working. So let's do that. I see that we have two files. We created two files, this hello controller, okay, and this other one, which is demo application, okay. So demo application seems to be part of demo, and then controller is in this separate file that I had to create, and then I created this, or folder I should say, a folder that I created, and then I created this extra file. So let's start here. I believe this is our main, well, it says main right there. So this is our main application, I guess you could say. Is this the entry point? Possibly. Let's copy and paste this, and then now I want to figure out what is the entry point. What is the entry point of a, and then I'm gonna put this in parentheses. Should I say Spring Boot application, or a Maven application, or a Java application? Whoops. What is the right question to ask? Okay. How is this entry point decided upon? Okay. So I'm trying to figure out, okay, well, I have some application. Obviously, here in this context, we have this main application. Okay, and it lives in this seemingly random location, right? Source, main, Java, com, example, demo, and then demo application, right? Like, how is this known to be the entry point? I think in the last video we said that Maven was controlling things. It said that it was like the orchestrator. Okay, well, so Maven is finding this location, or how is that working? How is this the entry point? Okay, that's a beautifully insightful question. Okay. What's the right way to ask? You could ask, what is the entry point of a Java application? Java application built with Spring Boot using Maven. Okay. Built with, okay. That deserves some coffee. All right. So Java application, and it's built using Spring Boot, or no, built with Spring Boot and uses Maven. Okay. So the language and runtime, Java Virtual Machine, okay, is Java. Spring Boot application, the framework that bootstraps and configures my application, yeah. Now Maven is the tool that builds and compiles and runs. So I'm guessing Maven is going to be the orchestrator. I think so. So the most precise question is, what is the entry point of a Spring Boot application? Okay. All right. So what is the entry point? In any Java application, the entry point is the method public static void main here. Okay. This is where the Java virtual machine starts execution. In a Spring Boot application, the entry point is the class that contains the main method. the class that contains the main method, okay, is annotated with Spring Boot application. So it has this annotation called Spring Boot application. Okay, yes. Yep. So this is the entry point because the Java virtual machine looks for main. Spring Boot uses Spring application.run method to bootstrap the application. What does it mean to bootstrap an application? All right, the annotation, Spring Boot application annotation, tells Spring to auto-configure and scan for components. Okay. Question number 2 is going to be in this sentence here. Let's see, scan for components. What counts as a component? As a component, and how would Spring configure them? Okay. So how is the entry point decided? The Java virtual machine looks for main method when you run a .jar file. I don't think I ran a .jar file. I'm guessing it was done under the hood, but when and where would this .jar file be ran? Okay. Spring Boot uses the class passed to Spring application run as the starting point to configure. Okay. So the class, which is demo application, is passed to Spring application.run. Okay. If you have multiple classes with main methods, you can choose which one to run, but only one should be annotated with Spring Boot application to avoid conflicts, okay? Maven doesn't decide the entry point, it just builds and runs your app, okay? So I believe I have a fourth question. In a large scale production Java application, okay, you have, and I'm trying to figure out how to actually write this, because this kind of goes to one of the questions that I have, which is about how components of a Java application can interact with other components which are also Java applications, right? So is it with microservice architecture, right? Okay. So the question that I'm going to be trying to ask here is about this application can have a main, but what if another application also has a main, but they're kind of running independent of each other? Yeah. If you have many, how do do I ask that? If you have many things that you're trying to keep track of, no, many what? Many uh, aspects of a project that are all working together and might have multiple mains. Maybe I am thinking of microservice architecture. Okay. So, what does it mean to bootstrap an application? Okay, to bootstrap an application means to initialize and start it up. Okay, so kind of like a bootloader, I guess. Loading all the necessary components, configurations, and services. Okay, so in Spring Boot, this happens when you call Spring Application Run and then you pass in a class and arguments. Okay, so I'm guessing we pass in this class and we pass in those args. Okay, this line starts, now they put the Spring application here above the class, not above the method here, the main method. So I'm going to try to figure out why is the annotation up there, but that's something we're going to figure out later, not right now. Okay, so this line starts the Spring application context, the container that manages your beans. What? Manages my beans? Okay. What does beans mean in this context? Okay. Loads and configures files like application properties. Okay, so application properties, that was in resources because we have this here. Okay, so I'm not going to focus on that too much. And starts everything. Think of it like turning a key in a car. Bootstrapping is what gets in the engine, or what gets the engine running and everything ready to drive. Okay, sure, whatever. Okay, what counts as a component? How does Spring configure them? In Spring, a component is any class that is managed by the Spring container. Any class that is managed by the Spring container. Okay. So I'm common component types. I'm trying to figure out what does that mean? There. Common types. So, okay, here's bean again. Method that returns a manually defined bean. Okay. Component, service, repository, controller, REST controller, configuration, bean. So I have those annotations, and those annotations are telling somebody either Spring Boot or the compiler, which should be Maven, right? Information about the thing. And I don't know what thing means in this context. Is it class? Or is it method? Or what's does it change based off of which one I'm using, right? Okay. How Spring configures them. Spring scans my code starting from the package of Spring Boot application class, okay? It finds classes annotated with the above annotation. So it can be plural. It creates instances of them called beans. Okay, well, here's where beans are. And injects them where needed using dependency injection. Okay. What is dependency injection? Okay. For example, we have this service annotation, okay? And it is above the class called greeting service. And then I have a public string greet. So I have a function called greet, and it just returns hello. Spring will automatically create a greeting service bean, greeting service here, matches there, and inject it into any class that it needs. Okay. When and where would a .jar file be run? You're right, you haven't run a .file yet because you're using this Maven. That runs your app directly from source code, but Maven can also package your app into a .jar, Java archive, okay, which is a bundled version of your app that can run anywhere within or with Java installed, okay? To create a .jar, I clean everything, okay? And then if I want to run it, I do Java and then jar and then give the target to where my jar is, okay? So now the question about large scale applications, okay? So in a monolith, there's going to be one main method, okay? One Spring Boot application, and all features live in the code base, in one code base, okay? Now, in a microservice architecture, each microservice has its own Spring Boot application. Okay, so we have many Spring Boot applications. Each has its own main method and a Spring Boot application. Services communicate over HTTP, messaging, or other protocols. So yes, in a large system, you may have many mains, but each one belongs to separate services. Question number three. In a large scale microservice, how do I keep track of which Spring Boot application, what did I call it? Spring Boot app, okay, yeah, goes to which main, okay? Even in a monolith, you might have test classes or utility tools with their own main method, but only one is the true entry point of the application. Sure. So, Here are my three questions here. Okay. What are beans in spring? Hold on, let me take a sip of water. I'm gonna take another one. Take a 10-second break. Hold up a second. Or 10. Okay. So, what are beans in spring? In spring, a bean is simply an object that is managed by the spring container. Okay? So the spring container manages a whole bunch of beans, I guess. And bean is a class. So I write a class, yes. I annotate it with something like component, service, or bean. Spring sees the annotation and says, I'll create and manage an instance of this class for you. So it's instantiated. So this, let's see, so a bean automatically gets instantiated because of the annotation. Spring seed, yeah, okay. Question number 2. What if I have multiple methods and member variables inside of a single class, and that class has an annotation? Okay. So here, keeps it in memory, injects it whenever it's needed. Okay, so this object is now a spring bean. So now, dependency injection. So I'm trying to kind of understand as much as I can, also figure out, like, hear all of these words, all of these terms, and then try to figure out how they connect to each other, figure out what they are, how they connect, and then even if I'm not able to figure out those two questions, maybe later I go and keep hammering in and watch videos online, right? Like, trying to absorb as much information as I can right now. Dependency injection. Okay. This is a design pattern where an object's dependencies are provided to it rather than an object creating them itself. Coffee. Okay. Design patterns. That is also something that I want to be able to learn about. Okay. So, why it matters: promotes loose coupling. I think you guys already know what I'm going to be doing here. What is loose coupling? So, as I keep saying, like, trying to find all of these like nuggets of concepts that I've never even imagined or thought of or encountered, And this project is that's the entire point of this project, is for me to be able to go in and stumble across these concepts and these ideas, and for me to be able to play with them, right? So, why am I doing Java? This is why I'm doing Java. Okay, that, like, here's the answer. Loose coupling. What is it? Who knows? I would have never known about it. How would I have ever stumbled upon this idea if I didn't do this project, right? How would I have known about dependency injection? Okay, but now I know at least that these concepts exist. I don't understand them. I have no idea how to apply them. I don't know what they're good for. I don't know anything about them, but I know that they exist. And now they're on my radar. Okay, so now I can go in and try to figure out, okay, well, if they're pretty important, I should pay attention to them. Then I can play around with those ideas. Then I can move forward, right? The ecosystem, which Java lives with. Okay, so this Let's Spring manage object lifecycles and wiring. Okay, so without dependency injection. I actually might want to, and I don't know if I'm going to have this question yet. Can you tell me more about dependency injection? So I haven't finished reading the dependency injection section, but I'm going to guess that this is kind of important. So I'm going to preemptively put that question in. Maybe that it does. Maybe this is really long and does a really good job, so we can take it out. But anyways, okay, so without dependency injection, greeting service. So this is the class name, okay, or the type. Greeting service is the type, right? Public class greeting service is and then service. So this is the object. This is the instantiation of a class of type greeting service, okay, is equal to new. And then greeting service method, which this method is probably automatically triggered, right? The constructor is triggered here. So that's another question, okay. Number 5 is here. I am noticing that I did not have an explicit constructor method in the greeting service class. So how can I call a constructor that doesn't exist? Okay. All right, so I get back an object. So I'm manually creating the dependency. How is this a dependency? Okay, so with dependency injection, Spring style, okay? REST controller. So I have this annotation here, REST controller, above a class, and this is public class hello controller, okay? Private final greeting service. Okay. Number 6. What does final mean in? Does it mean like const? Okay. private final greeting service. So I'm creating, so this is the type, okay? And this is going to be the instantiation of it. So I'm creating, I'm not doing equals new, so I haven't instantiated anything yet, but I am clearing the memory of size this class, okay? And allocating it, saying here's your memory, okay? So now public controller, okay? Okay. Question number 7. I am noticing that you have the exact same name for the class and a method within the class. How does this work? Okay. So now we have the this operator, so that's like the Python self, okay? Greeting service is equal to greeting service. Oh, okay. And greeting service is passed in here. Okay. And who calls this? And then say hello, return greeting service, which should be greeting service here, dot greet. Okay, I don't understand what's going on there. So Spring sees hello controller. It sees, again, I don't know if it's this one or this one. So I'm guessing it's this one. Needs greeting service. It needs greeting service here, right? And injects the bean automatically. Greeting service. I'm gonna press enter right now because it's taking up so much space, but we're on number 3. Okay, there we go. Now it's a little bit easier to read. I'm gonna take another sip of water. All right, so number 3. In a large-scale microservice system, how do you keep track of which main belongs to which app? So this is where project structure, naming conventions, and tooling come into play. Okay, so this is why we had to make this really weird file structure in this Java application. So it's kind of, we're following the conventions. At least that's what I think from reading the first sentence. We'll see about this. So each microservice is its own Spring Boot application. Okay. Each microservice is its own Spring Boot application. Yeah, that makes sense. Has its own main method. Yep. Has its own Spring Boot application. Okay. Has its own Spring Boot. Oh, that's that annotation that we saw above the class with the main. Okay. Lives in its own repo and subfolder module. Okay, so microservice, user service. Okay, so this is the main project. So microservices, multiple. This is a microservice, this is a microservice, and this is a microservice. Okay. All right, so we have 3 microservices. Each one has a source, main, Java, COM, example, user, and then user service application. user service here. User service application.java. This one is order service, and it has the source, the main, the Java, com, example. But now it has order, okay, order, and then order service application. Okay, same thing here, blah, blah, blah. So there's 3 applications in 3 separate folders, all following that same structure. Source, main, Java, com, example, and then name of the file or folder. Each of these have their own project object model, I think it was called, .xml, okay? Application properties, main method, and ports, okay? How to keep track. Use the naming, or just like name the files differently, okay? Use separate application. I guess my question right now is like, well, if, like, is this file right there the Maven that I'm calling? Or where is the Spring Boot that I am calling? But Maven calls Spring Boot, right? And so in the microservice architecture, it's going to be that I have Maven, which compiles this class, but then where is Maven living? And then I know that it had global scope. And then it's also calling Spring. Now Spring, where is Spring living? And how does it know to look in this location? Okay. So use Docker, Compose, or Kubernetes to orchestrate them. All right. 7 questions, and I think it's a long. Oh, it's not as long as I thought. Okay. So, does a bean get instantiated automatically because of the annotation? So, yes, when you annotate a class with component, service, repository, or define it with bean, Spring automatically instantiates that class at runtime and manages its life cycle. Okay, this is part of what's called inversion of control. Okay, instead of you creating objects manually, Spring does it for you. Okay. So what if a class has multiple methods and member variables? That's totally fine, and we kind of saw that above. Instantiates the class once. Singleton. Okay, so singleton is another, like, what was that called? Design pattern? Okay. Injects it whenever needed. Lets you use all of its methods and variables. So service, math service, with a counter and multiple methods, okay? Spring creates one math service bean, and all methods and fields are available whenever it's injected. So does that mean that the memory is shared? Like this counter is going to be shared over multiple injected locations. Is that right? Okay. So, loose coupling. Here we go. Loose coupling means that components like classes and modules are independent and don't rely heavily on other internal details. Okay. Tight coupling. User service, instantiation of user service, okay, equals new user service, new user repository. Okay. You're manually wiring dependencies, like if user repository changes, user service might break. Okay, so like if this changes, it's going to break this user service because it's no longer the valid class that it's expecting, okay? So loose coupling is going to be user service, and then I just create this user repository, okay? And Spring Boot will automatically just inject it in there, okay? So now Spring handles the wiring. User service doesn't care how user repository is created. Loose coupling makes my code easy to test, easy to maintain, more modular. Okay. So tell me more about dependency injection. So DI is when an object's dependencies are provided from the outside rather than an object creating them itself. Constructor injection, field injection, auto wires, setter injection. Okay. Service, public, service class, greeting service, public string greet, return here. Okay. REST controller, some class, another class. Spring sees this hello controller needs greeting service. This hello controller needs greeting service here, okay? And injects the bean automatically, okay? How can I call a constructor that doesn't exist? In Java, you don't explicitly define a constructor. The compiler provides a default non-argument constructor like this. Okay, cool. So what does final mean? Can only be assigned once. Okay, cannot be reassigned. Okay, so it's like const. Same name for class and method. So this is a misunderstanding in Java. A constructor has the same name as the class and no return type. A method has a return type and can have any name. Okay, so that's the constructor. That's the constructor. Okay, fine. Okay, so I think I am going to take a little bit of a break right here. I can feel that my brain is a little bit tired. In the next video, we are going to continue to try to understand what we have here, because there is a lot of information. Then once we get to the point where we kind of understand what's happening with this very basic application that we created, next step is going to be, okay, let's make it a little bit more complex. Let's try to play around with things. Let's try to see what we can do and move forward with this project. So if that is interesting, subscribe to this channel, and I would love to have you along on the journey. I hope you have a wonderful rest of the day. My name is Timothy Lee Grant, and see you very soon.